Okay, in the second video here in Chapter 8, what we're going to look at is writing chemical equations and balancing them. So we're going to put the reactants and the products into chemical reaction form, into an equation, and we're going to need to use our naming skills, our nomenclature from Chapter 6 in order to take the names as words of the chemicals and to put them into symbol form. So let's start by an example. Here it says, a balloon is filled, this is an example of a chemical reaction. A balloon is filled with hydrogen and oxygen gas, explodes when heated. The product is water vapor. This is an example of a chemical reaction. Many times chemists observe chemical reactions and they will have to take their observations and put them into chemical equation form. So that's exactly what we're doing here. Remember that we always have reactants produce products. And sometimes there's special conditions for the reaction to take place. So how do we know a reaction even took place here? It says a balloon filled with hydrogen and oxygen gas explodes. That word explodes, explosions are descriptions of chemical change. So when something explodes, we know a chemical reaction occurred. What reagents were involved in the chemical reaction? Well, the balloon was filled with hydrogen and oxygen gas. So our reagents are hydrogen and oxygen gas. Our reactants. Were there any special conditions in which when you put hydrogen and oxygen gas together cause the explosion? There were. Notice that the reaction or the reactants were heated. So our special condition is going to be heat. It says the product is water vapor. So water vapor is what is produced by the reaction. So let's write a chemical equation just to put the names of the compounds, reactants, and products in symbol form. So we said our reactants were hydrogen and oxygen gas. Hydrogen is not just H. We know hydrogen is an element, but if you recall all the way back to chapter 3, I believe, hydrogen is a diatomic element. So when we talk about hydrogen gas, when we say hydrogen, we understand as chemists now that it's H2. All right. Oxygen is the same way. Oxygen gas, oxygen is a diatomic element. So when we write the formula, we write O2 for oxygen. And it says it reacts when it's heated, so I'm going to have my chemical reaction arrow, an arrow with a head at the end. I'm going to put the symbol for heat, the triangle above it. And it says the product is water vapor. Well, we know that water is H2O. What does vapor imply? Well, vapor is the form of water when it's in its gaseous form. So here's our chemical reaction written as an equation. Hydrogen plus oxygen gas yields, that's what we say when we have an arrow here, yields or produces water. This is the unbalanced chemical equation. We're going to need to learn how to balance chemical equations because we have this law in science called the law of conservation of mass. It says that matter can't be created or destroyed, it can just be rearranged or transformed. So I'm going to start with my equation here. Now, in the chemical reactions we're going to be looking at in this class, we're not going to be looking at nuclear explosions where the nucleus breaks open and the subatomic particles spill out and the protons and the electrons and the neutrons are everywhere and they're changing. We are going to keep atoms as atoms. The chemical reactions we are going to be doing in this class are taking the atoms or ions that are bonded together, and we're going to be breaking and reforming bonds with the same number of atoms we have. So the number of each type of atom on the reactant side should always equal the number of each type of atom on the product side. For instance, the number of hydrogen atoms on the reactant side should equal the number of hydrogen atoms on the product side. We're going to do this. We're going to balance a chemical equation, if it's not already balanced, by using coefficients, those numbers in front of the chemical symbols, or the formulas. The coefficients will tell us how many of each reacted, kind of like in a recipe. When you go to bake like a cake, for instance, when you read the back of the cake boxes, you've got 1 box of cake mix, you're going to add so many cups of water. You're going to add a cup of water, a third a cup of oil, and you're going to add 3 eggs. and you're going to produce one cake. That recipe is really what a chemical equation is. The coefficients tell you how many of each reagent you need to form, or reactant to form how many of the product. So we're going to figure out the coefficients, or the balanced reactants and products, by balancing the atoms. So the way I like to start this out is by writing all the types of different atoms I have in my chemical equation. And I usually just read left to right. So I'll go, on the reactant side, what type of atoms do I have? Well, I see that I have hydrogen atoms and I have oxygen atoms. Those are the only two types of atoms I have. So I like to keep stock of those. Now I'm going to record initially how many of each atom type I have. On the reactant side, I have 2 hydrogen atoms. On the product side, I have 2 hydrogen atoms. So I've got the same number of hydrogen atoms on the left as I do on the right. We would say that hydrogen was balanced. Check. We don't have to worry about it. Okay, let's move to oxygen. Do I have an equal number of oxygen atoms on each side? Well, on the left-hand side of the equation, I have 2 oxygen atoms in the reactants. And on the right-hand side of the equation, I only have 1 oxygen atom. So we see here that we do not have a balanced number of oxygen atoms on the left and right. What we're going to do is we're always going to take the side that's lacking, the lower number, and we're going to multiply it using a coefficient to equal the side that has the more. So basically, on the product side, I only have 1 oxygen atom. I want to multiply that by something, some coefficient, to where it equals the other side, 2. So 1 times, obviously, 2 equals 2. So the coefficient that I'm going to be using will be 2 in front of the oxygen. But because oxygen is part of a molecule, I'm going to write the coefficient 2 before water. So we're going to produce 2 waters in this equation. So now when I go back to balance my oxygens, is it 2 on each side? Well, we still have 2 oxygens on this side, but now the water has 1 oxygen in the molecule. It's understood, but we have 2 molecules. So it's 2 times 1, or 2. Now, why did we do this? How come I didn't just change the subscript from H2O to H2O2 to get 2 oxygens? That would be bad, okay? What does hydrogen and oxygen gas, when heated, what does that produce? It produced water. Is H2O2 water? The answer is no. That's hydrogen peroxide. Would you drink hydrogen peroxide? I wouldn't, especially the pure form, which is strong oxidant, very acidic, not the same thing as water. So we never want to change the chemical identity when we balance an equation. We only want to balance using coefficients in front of the formulas to tell how many of that compound or element were formed. Now, something happened here. We balanced the oxygens, but you notice we put the 2 in front of the water. Do we still only have 2 hydrogens on the right-hand side? Actually, we have 2 times 2 hydrogens. So on the right-hand side, we now have 4 hydrogens. 4 is not the same thing as 2. So now we have an unbalanced equation again. Did I do something wrong? No, this is part of balancing a chemical equation. It's a process. You're going to go back and forth. Erasers are best, so use erasers. They're good. And you're just going to go back, and sometimes you're going to have to play with it. So now I have 2 hydrogens on the left and 4 hydrogens on the right. Now I'm lacking on the reactant side. What can I multiply 2 times so that I get 4 on this side as well? I want to balance it up. Never balance it down, always balance it up. So 2 times 2 is obviously 4. So the coefficient that I want to put in front of my hydrogen on the left-hand side is 2. When I do that, let's rebalance or check our balancing again. Now for hydrogen, I have 2 times 2, which is 4. And on this side, I have 2 times 2, which is 4. For oxygen, I still have 2 on the left side, and I have 2 times 1, which is understood. On the right-hand side are 2. So now I've got all of my atoms balanced. I've got a completely balanced chemical equation. So let's look at the full balanced chemical equation. Every time you write an equation in this class, you have to balance it. So let's read what our recipe is for making water, okay, with hydrogen and oxygen. It's really what this chemical equation is. If you want to make water, what amounts of each reactant do you need? You need 2 hydrogen molecules for every 1 oxygen molecule, and if you put those together, you'll produce 2 water molecules. That's the balanced chemical equation. Okay, let's just practice balancing some more equations, because you can practice, and for each person, the amount of equations they practice balancing until they feel like they're comfortable with it and they can do it in a reasonably fast time is going to vary. So just keep practicing. There's tons of equations you can balance in your book too. So look at your book, go to the end of the chapter, just find tons of equations to work on. All right, let's start with the first one here. The first chemical equation we're going to look at says ammonia yields or produces hydrogen plus nitrogen. So let's balance that equation. The first thing I'm going to do the same thing I did before. So I'm going to take stock of all the different types of atoms I've got. So in this chemical equation, I've got nitrogen and hydrogen atoms. I'm going to count how many I have on each side of the equation. So on the reactant side, I have 1 nitrogen atom. On the product side, I have how many nitrogens? I have 2. So we're balanced? No. If I add the coefficient 2 in front of the ammonia, instead of having 1 nitrogen, I have 2 times 1, or 2 ammonia atoms, or 2 nitrogen atoms. So if I add this coefficient 2 here, now I've got 2 on each side. The nitrogen will be balanced. Okay, let's go to the hydrogens now. How many hydrogens do I have on each side? Well, now, so because I've got the coefficient 2 in front, that applies to the entire molecule of ammonia. So, I've got 2, and how many hydrogens in ammonia? Times 3. So 2 times 3 is 6. I've got 6 hydrogens on my reactant side. How many hydrogens do I have on my product side? 2. How do I make 2 a 6? 2 times what is 6? You're probably pretty good at this. 2 times 3 is 6. So in order to make the hydrogens on the left and the right match, I need to add the coefficient 3 to the front, because 3 times 2 is 6. Alright, is my equation balanced now? I always go back and I check everything one more time because I'm paranoid. Sometimes when you change a coefficient, sometimes it can change another atom that you've already balanced. So the last step to balancing a chemical equation is always to go back and check that every atom is balanced. So let's do the nitrogens first. I've got 2 times 1, or 2 nitrogens on the left. I've got 2 nitrogen on the right, so nitrogen's balanced. Let's do the hydrogens. I've got 2 times 3 on the left, which is 6, and I've got 3 times 2 on the right, which is 6. So the hydrogens are balanced too. So as it turns out, this chemical equation, 2 ammonias produce 3 hydrogens plus 1 nitrogen, is a balanced chemical equation. All right, let's look at one more here. The next equation we're going to look at is, we'll just read it. It says cobalt plus copper 2 sulfate yields cobalt 3 sulfate plus copper. All right. Now, do you notice something in this chemical equation? I'm going to point this out as a tip to you. Do you notice how I have a polyatomic ion here? Those polyatomic ions, if they appear on both sides of the equation, see how I have a sulfate on the left-hand side and I still have that polyatomic sulfate on the right-hand side? It seems that the sulfur-oxygen atoms did not break the bonds. Those bonds remain constant, or they acted as a unit throughout the entire chemical equation. The advice I'm going to give is, rather than separating the sulfur and oxygen to balance them out, keep sulfate the same. Alright, so keep it as a unit and balance the sulfate itself. You'll see what I mean here when we take stock of what we got. Because we've got cobalt atoms, we've got copper atoms, and instead of saying sulfur and oxygen separately, because they remain together as a unit, I'm going to balance sulfate as a unit. This will save me time. One of the things that you're going to notice is that a seasoned chemist, somebody who's done chemistry for a long time, is going to be much faster at balancing equations usually than a beginner. And it's not that they're any smarter or can figure it out better. It's just that they know the tricks to balancing quickly. So that's one of our tricks. All right, let's balance the equation now. Let's start with cobalt. On the left-hand side of the equation, we have 1 cobalt atom. On the right-hand side, we have 2. So obviously, this is not balanced. How do we balance up? Remember, always balance up. So how do we make the 1 a 2? Well, we just put a coefficient of 2 in front of the cobalt. So now we've got 2 cobalts on each side. Okay, cobalt's balanced for now. Let's go to the next atom. The next atom is copper. We've got 1 copper on this side. We've got 1 copper on that side. Each side has 1 copper. It's balanced. We don't have to add any coefficients. The copper is balanced as is, the copper 2 ion. Now, the third thing we're going to look at is sulfate. We're going to look at this as a group, and what we notice is on the left-hand side of our equation, as a group for sulfate, we only have 1 SO4, because we're balancing the whole SO4. Some people will say 4. We only have 1 SO4 unit. How many do we have on the right? On how many SO4 units on the right-hand side of the equation? Do you notice outside of the parentheses there's a 3 there? We have 3 sulfates. So are we balanced on sulfates? No. We need to balance up. We need to change this 1 to a least common multiple, or we need to change it to 3. So on the reactant side, do we put a 3 as a subscript? No, we don't have 43 sulfates. We don't have 3 sulfates in 1 copper. We're going to make that 3 by adding the coefficient. So when you balance, it's always coefficients. So now I've got 3 sulfates, 3 SO4s, and I've got 3 SO4s. Okay, now what happened when we put the 3 there? When we put the 3 to balance the sulfate, it also changed the amount of coppers we have. So I'm going to come back here on the reactant side now. I have 3 coppers. How many do I have on the product? Well, right now I only have 1. I can easily make that a 3 though, right? Just put a 3 in front. Okay, so now when we read the chemical equation, it's balanced. You can go ahead and check it in. But 2 cobalts reacts with 3 copper 2 sulfates to produce copper 3 sulfate plus 3 coppers. That's our balanced equation. Let's look at one more, okay? So the last one we're going to look at here is hydrochloric acid plus ammonia produce ammonium chloride. All right. Now here I don't have any polyatomics on both sides. I see my polyatomic ammonium here, NH4, but I don't have any NH4s on the other side. So we're just going to balance this once again like we were previously, atom by atom. So what type of atoms do we have here? Read left to right. We've got a hydrogen, we've got chlorine, and we've got nitrogen. And of course we have a hydrogen again. Notice this time that the hydrogens are split up. There's hydrogen in 2 of the reactants. So when we balance it, we're going to have to make sure we keep track of all the hydrogens present. Okay, let's go. Let's balance one atom at a time. So we're going to start with hydrogen. We've got 1 hydrogen in HCl, hydrochloric acid, and we've got 3 in ammonia. We're going to add those. See the plus sign here? When they're in different reagents, you add the amounts. So we have 4 hydrogens on the left. How many hydrogens do we have on the right-hand side of the equation? We have 4. So the hydrogens are balanced. We don't have to add coefficients. This is the part that makes people nervous. They think, wait, this is already balanced. I didn't add any coefficients. Am I doing something wrong? No, just keep going. You don't always have to add coefficients. So let's go to chlorine. We have 1 chlorine on the left. We have 1 chlorine on the right. The chlorines are balanced as well. Okay, let's go to the next one. We have 1 nitrogen on the left, and we have 1 nitrogen on the right. The nitrogens are balanced as well. Now wait a second. Are you telling me that everything's balanced and I don't have to add any coefficients? Yes. Some reactions are balanced as written. You don't always have to go back and add coefficients to balance a reaction. This unnerves people. Like in an exam, they're like, what should I do? Should I add 1s all over the place? They start getting nervous, like it's a trick question. It's not a trick question. It's just that the equation's already balanced. Don't add the 1s, by the way. It's understood that you've got 1 of each. We typically don't write the 1s unless we're using it as an example. So some equations are just balanced as written. Okay, now what are you going to do? For balancing chemical equations, the best thing to do is just practice, practice, practice. So go in the back of your book. I promise you'll find some that you can go ahead and you can practice in the back in your suggested problems. Some people are very quick at this. Some people, maybe it's a weak point. So just practice as many as you need to, okay?